Okay, so let's talk about surface area. Surface area. So what is surface area? This is the sum of areas of all faces of a shape. So if we look at a solid shape, you realize it has different faces. If you can calculate the areas of all the faces and then sum that up, that gives you the surface area for that particular shape, right? In other words, what is the area of the exposed surfaces? So now let's look at something simple for demonstration's sake. We'll look at a rectangular block here. So let's say this rectangular block has 4 centimeters height, 5 centimeters width, and then 10 centimeters length there. Now, how many bases does this thing have? This thing is going to have many faces. If we're gonna look inside, it's gonna go like that. Okay, so this shape has got a face on the inside there, shape on the other side there, shape on the other side there, and then it has these exterior faces, this one, and that one. So a total of 6 faces, right? Now all these faces are simply rectangles. So all we need to do is find area of 6 rectangles. So the first rectangle we can look at is this one here, which is 5 times 4, right? So it's 4 times 5. That's the area of this thing. Now what we realize is that this face and the face at the back there are exactly the same. So there's no need for us to calculate this area twice. We can calculate it once and then we can multiply it by 2, right? Because it's now representing 2 similar faces. From there, we can calculate the area of this face here, which is 10 and 4, because it's equal to that. So this is going to be 10 times 4. But again, this face here in front is the same as that face at the back there. So instead of calculating these two areas separately, we can calculate it once and then multiply by 2 to show that there are 2 faces which have that area. Lastly, we've got the area at the bottom of this rectangle here at the bottom, right? Which has a 5 and a 10. So our area of that one will be 10 times 5. But this one at the bottom is the same as the area of that shape at the top. So we multiply by 2 and get that. So it's going to be 2 times 20 plus 2 times 40 plus 2 times 50, which is going to be 40 plus 80 plus 100, which is going to be 220 centimeters squared. So that is the surface area of that block. We simply found the areas of all the faces and added them up. Now you can have other shapes, for example, a cylinder. If you look at a cylinder has 2 faces that are circular and then one curved part. So it's got the top part, it's got the bottom part, and then it's got the curved part. The top part is a circle and the bottom part is also a circle. So the area of 2 circles will be 2 times the area of 1 circle. Area of a circle is pi times the radius squared. So 2 of those circles, their area will be 2 times pi r squared. Now, the curved part, which is not a circle, its area is found by 2 times pi times r times h, where h is the height of the cylinder. So this is the area of the two circles, and this is the curved part there. If you add the area of the curved part to the area of the two circles, you find the total surface area of the cylinder. Now, last, we'll look at a cone, right? We have a cone. So earlier on, we identified that a cone will have a perpendicular height h and a radius r. But what we didn't identify was a third measurement we can take from a cone, which is the slant height that we call L. So L is the slant height. Don't confuse the slant height with the perpendicular height h. If you're going to find the surface area, you need to know the slant height. The slant height is given by square root of h squared plus r squared, where h is the perpendicular height and r is the radius. So this is how you calculate the length of the slant height. So if you're not given the length of a slant height in a question, just use this simple formula here to find the length of the slant height. For those of you who can understand further, you'll see that this is simply a right-angled triangle. And by looking at this right-angled triangle, I used Pythagoras theorem to find L. L squared is equal to h squared plus r squared. You move the square to the other side, it becomes square root. So L is equal to square root of h squared plus r squared. So if you are able to see how Pythagoras theorem is applicable here, that's a bonus. If not, you can just take this formula and use it as is. So now, what's our surface area? Well, there's two areas we have to look at. The first one is the curved surface area, which is the surface area of the curved part alone. Only the curved part, excluding the circle at the bottom. So the circle at the bottom, we don't include it on the curved surface area. So the curved surface area is simply pi times radius times the slant height. Pi r L. Pi r L. That's the curved surface area. Now, you can look for the total surface area. The total surface area now includes the circle at the bottom. So it will be pi r squared. That's the area of the circle at the bottom, plus pi r L, which is the area of the curved part. So that's how you find the total surface area of a cone. So you can find the curved surface area alone, or you can find the total surface area by simply adding the area of the circle at the bottom and the area of the curved part of the cone. So that's where we stop. No, before we stop, let me show you one more thing. Before we stop, let me show you a sphere. Now, remember our sphere is a ball, right? And what we know about the ball is the radius. Surface area of a sphere is given by this formula, 4 times pi times radius squared. That's the surface area of a sphere, 4 times pi times radius squared. So you will see in the questions how you can apply these.